Okay, so I'm going to go over some of the basic conversion of logic gate circuits to what are called Boolean formulas or Boolean equations, and then also going the other way, going from a Boolean equation to a logic circuit. So let's start with a simple example. Let's take an AND gate here. And we're going to take the output from the AND and go into an OR gate. Typically, we're going to call these inputs, for example, A, B, C, and the output we'll call X. So one of the things we want to do is determine what is the equation that describes this circuit. This is more of a schematic, but not that all the parts are there. We don't know the pin numbers or the connections to the device or even what the device looks like, but it's kind of a representation of the circuit. So let's take a look and see how we can actually determine the equation. So one approach is kind of going from the left to the right and kind of looking at this in kind of sections. So we can kind of look at the output of the AND gate as one section. We can write this output here as A and B, and that's written just AB like that. And then we can kind of bring this term over here, the C term, it's just a wire over to this point. And then we can OR those two terms together. So we'd write this as X equals A and B or C. So that would be the Boolean equation. Now let's do a little bit more of a complicated example. Okay, in this case we have four. A good starting point here is to make sure you know the type of gate that you're starting with. So we know that's an OR gate, so we can kind of write that as a plus symbol, even though that represents OR. And this is an AND gate, which is multiplication. The inverter simply inverts the signal. So let's do the same thing we did last time. Here, the output of this OR gate is going to be A or B. What's this output going to be here? Well, it's the complement of C, and the way we write that is a C with a bar on the top. And then this input here on the bottom is just D. Now we're going to AND all these terms together. But what's important is, just like with math, we need to kind of keep track of order of operations and to make sure that we don't just mix everything together. And so the way we typically do that is that if this is an output from a specific gate, I'm going to write here X equals, I'm going to put those in parentheses to make sure we don't accidentally AND it with the wrong terms. And then we're going to AND that with C naught and D. And again, remember that the ANDing process or the ANDing function is kind of like multiplication. So for example, if you have 3 times X, we often write that as 3X. We leave out the multiplication symbol. But sometimes they also still will use the dot. So sometimes you see a dot representing ANDing. So that's a little bit more complicated. Let's change this up a little bit. What if we complement the output right here? What if we have a bubble here? Now this gate is an OR gate, but if we invert the output, it is now called a NOR gate. So what would that change on our equation? Well, the output there would then be A or B naught, and then that would change that whole term to be complemented or inverted. Lastly, let's do one more change here. What if we had this as, instead of an AND gate, a NAND gate? Like that. Now that means the whole thing is going to be complemented. So we'd have to write a bar over the entire equation. Now, we're not going to be doing what's called Boolean reduction, where we try to kind of reduce the circuit or change it. So that would be the final expression there for the circuit. So those are some examples of where we're taking a circuit and creating the Boolean equation from it. And again, kind of following this left to right process is very helpful. Now let's go the other way. So now we're going to start with a Boolean equation. and see if we can draw the logic gates. So there are a couple approaches to this. We can see that these two terms are ANDed together, A and B, and that C or D are inverted on the output, but it's an OR operation. So we can do this a couple of ways. One recommendation that I have is to try to kind of break it up into the big parts here. We know that we have this term ORed with this term. Those are two kind of sets of terms that I can see there. And so I'm going to start with a big OR gate, kind of at the end here. And then the output is going to be X. And then we take a look at the first term. We have A and B. So that means it's ANDed. So we can write that as the inputs A and B. Those are ANDed together. But what is it ORed with? It's ORed with C or D not. Now, the one way we kind of look at this is like an OR gate here, but there's a bubble because the output of the two terms is complemented or inverted. So that's kind of a messy looking OR gate. Yeah, let me try that again. Okay, that's a little bit better. So now we have A and B here ORed with C or D not. So I'm going to write C or D, but because the whole term is inverted, we have the bubble there. Let's do another quick example. Okay, in this case, we've got X equals A or B or this term C naught and D E. So again, I can kind of see this as three inputs here to an OR gate. A, B, and then this term here. So I'm going to draw this as a 3-input OR gate. And the first term here is A. The next term is B. And then we have C naught ANDed with D and E. Well, since C is inverted, we know that that has to be complemented like that. And then that is ANDed with D and E. So first of all, D and E are ANDed. And then those two terms are ANDed together. It's a little bit messy, but you kind of should get the idea there, hopefully. And then the output is X. Now, there are a couple other ways we could have done this. Theoretically, we could have made this a 3-input AND gate and had the three terms connected together, C and not, and D and E. That's a way of doing it. But because these are kind of put in parentheses, it's kind of implied that that's a separate gate. Now, how you can double check this to make sure it's correct is kind of doing the same process backwards, like we did in the beginning. I'm going to put an A here, B here, and I'm going to kind of work this way. I've got C naught here, so I have C naught, and then we have D and E. So if we look at this output here, we have C naught ANDed with D and E. And if we AND that with A and B, or that with A and or B, we end up with A or B or C naught and DE, which checks with what our original equation was. So in your homework, you're going to have chances, some opportunities to go through and practice doing this. If you take your time and systematically do it, it's not too difficult. If you get stuck, feel free to drop in on office hours, assuming my internet's working. And but in the meantime, see if you can work through these exercises and complete them.